Now we can discuss about a very important theorem, Leibniz theorem in differential calculus. So the Leibniz theorem, the statement says that if u and v be two functions of x having derivatives of nth order and y is equal to uv, then yn, the nth derivative, is equal to nc0 unv plus nc1 un minus 1v1 plus nc2 un minus 2v2 plus etc. The general term is ncr un minus r vr plus etc. plus ncn uvn, where ncr is equal to n factorial divided by r factorial into n minus r factorial. This theorem is used for finding the nth derivative of product of functions. So let us see how the proof goes. So the proof of this theorem can be done with the help of mathematical induction. We are doing with the method of mathematical induction. So we have y is equal to uv. Then its first derivative is the product rule we are going to apply. Product of two function. We can find the derivative of product of two function as first function integral of derivative of second plus second function into derivative of first. So even if the order changed also, it is not going to matter as it is the sum of terms here. So you could see that y1 is u1v plus uv1. Let us move on to the differentiation of once again, that is the second derivative. What are we going to get? Y2 is equal to, you can see two terms in y1, which is a product expression. Both are product of two product functions of x. So we have to apply product rule for each and every term. So what is the product rule when you apply? What you are going to get for u1v? It is the second derivative of u1, u is u2, or the derivative of u1 is u2 into the second function we kept as it is, plus first function we retained, derivative of v is v1, plus. Now for the second term, we can do the differentiation. It is derivative of u is u1 into v1 we retained, plus then first function u we retained, derivative of v1 is v2. So we are getting four terms in the second derivative. And I can rewrite it as, so you can see that the second term and third term is the like term. So we can add them together. So what are we getting? y2 is equal to u2v plus 2 times u1v1 plus uv2. Now, this same expression I'm going to express with the coefficient, the binomial coefficient we can call is NCR is the binomial coefficient, and according to the formula, we can rewrite it as, it is the coefficient of u2v is 1, and here the second order derivative only we are finding. So I can express here n is 2 and r we can take it as 0. So 2c0, the value is 1. So 1 is replaced with the 2c0, u2v plus next is 2c1. And what is 2c1? 2 factorial by 1 factorial into 1 factorial, which is going to be 2. Okay, so that is 2c1 u1v1 plus next is 2c2 uv2. Thus, the theorem, we can say that the theorem is true for the results n equal to 1 as well as n is equal to 2. Now, assume that the theorem is true for n equal to m. If the theorem is true for n equal to m, what can we write? Ym is equal to mc0 umv plus mc1 um minus 1v1 plus mc2 um minus 2v2 plus etc. plus mcr minus 1 um minus r plus 1 vr minus 1 plus mcr um minus r into vr plus etc. plus mcm uvm. Now we are going to suppose that, okay, we have to check whether the theorem is true for m is equal to m plus 1. So for that, we are going to differentiate this equation ym is equal to the RHS, differentiating both sides with respect to x. What are we going to get? Derivative of ym is ym plus 1. And each and every term, no, you can see that two terms are going to come. Why? Because every term we need to apply product rule. So MC0 into the derivative of UMV is UM plus 1 V plus UM V1 plus. From the second term, we can write the product rule MC1 into UM minus 1 V2 plus UM V1, okay, etc. I can write for MC2 also, this third term also we can do the same thing. And you can see the MCR plus R minus 1, what is going to come? The derivative of MC R minus 1 into UM minus R plus 1 VR minus 1 is, it is MCR minus 1 into UM minus R VR minus 1 plus UM minus R plus 1 into VR plus, now the derivative of the next term is MCR into UM minus R minus 1 VR plus UM minus R into VR plus 1. Okay, last term plus etc. The last term is MCM U1 VM plus UVM plus 1. And now we can rearrange these steps. So what are we going to get? MC0 UM plus 1 V plus. Now you could see that UM V1 is repeated 2 times. Okay, it is UM V1. So the coefficients or the term within the brackets are going to be MC0 plus MC1 into UMV1. Similarly, we can write for each and every term. You can see now UM minus 1 V2 is going to repeat in 2 different terms. So that is going to be MC1 plus MC2 into UM minus 1 V2, etc. Or I can write MCR minus 1 plus MCR into UM minus R plus 1, UM minus R plus 1 into VR plus etc. plus MCM UVM plus 1. Or you can now, what are the terms? You can see this result you have already studied in your 11th and 12th classes, that MCR minus 1 plus MCR is nothing but MCM plus 1 CR. So, and again, these are also a common results, MC0 and M plus 1 C0, whatever be the number over here on top, if it is matching with the C0, then the values are going to be 1. Same is the case for MCM or M plus 1 CM plus 1. Both are going to be 1. So substituting all those in the results given in the previous equation, we will be getting ym plus 1 is equal to m plus 1 c0 um plus 1 v plus m plus 1 c1 um v1 plus m plus 1 c2 um minus 1 v2 plus etc. plus m plus 1 cr um minus r plus 1 vr plus etc. plus m plus 1 cm plus 1 um plus 1. And after replacing, okay, m plus 1 c naught with 1, again m plus 1 c m plus 1 with 1, okay, you could see that the result is true for n is equal to m plus 1, okay. Or even if you are not writing this binomial coefficient over in the first term and also in the last term, the result is going to be the same. So we can say that the theorem is true for m plus 1. So we can conclude that by mathematical induction, the theorem is true for all positive integral values of n, and hence proved the theorem.